Hello guys, this is Virender Singh and welcome back at our Milton second one tutorials. In the last one tutorial, we'll learn about the basic concept about the Milton, and I will show you that the simulations for that how that part should be cutting on the machine and what is the complete process for that. And in this video we'll learn about that how we can program that one component with the help of a Milton machine. So we will start from the very beginning and very basic. If you don't have the knowledge of the basic of the Mastercam, like as a lathe toolpath, like as a mill 2D toolpath, like as a mill 3D or a multi-axis, first go and learn all these things, because all these things and all these toolpaths are important before we learn the Milton, because the toolpath should be the most toolpaths should be the same, but some concept and some minor things should getting to be changed. So now let me start from the very basic and the beginning, that how this Milton, that one component that we can create with the help of a Milton machine. In a turn mill machine we already create that same tool part, but now we will create with the help of a Milton machine. And if you don't have the Milton machine, so what you have to do first, the Milton module is available for all the demo versions from the Mastercam 2023, and where the post files are also you can getting the access. So if you don't have the Mastercam 2023 demo version, I already created the video that how you can create and how you can get Mastercam 2023 demo version. If you are still facing issue, you can contact us. I will try to help you. So once you install the Mastercam 2023 demo version, you can go the Milton and manage list. In a manage list you will getting the Milton machineries like as a Fanuc mill, Fanuc Milton, LX, you will get a Fanuc DS, TC, the Fanuc generic lathe, the Milton LTZ, LTX, LTZ, SR, SR2, SR, TC and DT. All these kind of different kind of Milton machine which are available in the market. So you can choose all these machine. You can just click on add, and you can choose the machine. But for this one, that one component I am trying to create with the help of a Mazak 100 ST. Once I click on a select a machine, so that time new window is getting to be open, and it will open the machine things and something more details. And now at here one new window is getting pop up. Now at here we have to defining some basic concept and some basic details, like as we have to defining first, that is work holding. It means if we have to defining that device which help us to holding our work. So first we have to click on a work holding. At here in a work holding we can define the spindle. By default it's a 6-inch, but we can change the things. We can click on right at here, and at here we can change the things. If we want to change the spindle, we have to double click on right at here, and we can change the thing also. For example, for this one I want to change the inner diameter, so I can make the diameter is 70 mm. Similarly for the second spindle I have to double click, and I can make this one is 70 mm. That thing is depending on us, and we can also say that is depending on the machine standard, so that we can getting from that one. The work support, the steady rest, you can also defining the steady rest in the next step, that is setup over type, means how our workpiece is going to be set up. So right at here first we have to defining the initial spindle, means when we starting to work on our Milton machine, so how my workpiece is holding. It is holding in left spindle or is it holding in a right spindle. So we have to defining, for example now we have to holding this one in a left spindle, so just we have to click on a left spindle. In the next step we have to define the stock type. In a stock type there are the multiple options, like as we can use live with the help of a bar feeder, we can use with the help of a single piece, we can use with the two separate piece. So there are the multiple options at here. So we have to learn the basic things about all these options. If I just want to explain a little bit about this one right now, and in future we will learn about the detail also. For example, the first one is continue bar stock. In a continue bar stock we can use the pick off, stock pull and cut off. It means we have one continue bar stock with the help of bar feeder, and on a machine what we can do, we can pick off. It means we can second spindle can came and hold the workpiece. Stock pull, it means it can clamp the stock and it can pull, and also we can cut off, it means we can also parting. In a second one, continuous bar stock. In a continuous bar stock means right at here, as you can see, what we can do, we can pick off and cut off. It means at here stock pull is not available. It means if I want to make one piece and once I completed the piece, I want to take it in a second spindle, it can be going in a second spindle, but it that time stock should be not pulling outside, where I holding the part, it is getting to be cut from that one position. In this next step, single piece of stock, we can define, okay, I have a single piece and I have to just do the pick off and cut off, no stock pull. In a single piece of stock where we have to just pick off, it means we have to, there no cut off is required, we will just pick up our workpiece and take it in a second spindle. In the next step, there is a single piece of stock where, so that kind of that we are using when we have a single spindle machine and two separate parts, means we can work one part working on a left spindle and second part working on a right spindle. So there are the multiple options are available right at here. And now for the example, this one, we will use a continue bar stock where we can also perform the pick up and cut up operation. In the next step, the WCS, it is showing good from the top, and now we have to defining the left spindle. Right at in a left spindle, first thing is we have to define the part geometry. What is our part and what is the geometry? So in a part geometry, we have to click right at here and just click on this and end selection. So that is, we are defining the part geometry. Then in the next step, we have to click create turn profile. It means it is going to be created the turn profile at the upper as well as the lower, both side. In the next step, we have to click on a bar stock. It means where is my stock, and if we want to give some extra material, so we can define right at here. So this is my diameter, and if I want to give the extra material, for example, I am just defining 1 mm in OD, 1 mm in face and 1 mm in backside. Then the next thing is tool plane origin Z. This should be as currently now, and now after that stick out. Stick out means how much my workpiece is getting out from the spindle. Just you have to click right at here and just ping this point. It means my workpiece is getting to be hold right at from here, and this area should be outside from this. After that, we have to came in a right spindle. In a right spindle, we have to defining the pick off. What we have to define in the pick off, they have to define two things. That what is first thing is when it came the second spindle, so where it is going to be hold my workpiece, I just say it can hold from this one position. And cut off means we have to defining a tool which is we are using to cut this one portion. So we have to just click on right at here, just move this one tool and just I select this one tool and just okay. Once I select this one tool, so automatically take the tool width. Make sure you have to choose all these things in a perfect and a proper way. If you miss anything from that one portion, anything, so that time you will getting issue with the when you are creating the tool path, when you are creating the project, and multiple issues would be getting. So you have to make sure you have to check all this point in a proper way. First thing is you have to defining the stock setup in a proper way, that what according to the machine, according to the working area, you have to defining the workpiece type in a proper way. After that, you have to define the left spindle. In a left spindle, you have to define the part geometry. You have to define your part, the margin of my part, how much margin of my part, and after that we have to defining the where we have to hold the workpiece. In a right spindle, we have to defining pick off where we have to hold the workpiece and the tool which we have to choose, all these things, and just say okay. Once I just say okay, so automatically something's getting happen, and this is my part left for the left spindle and this is my part for the right spindle. So all things are getting successfully done. Now I can start to work on this machine. So for the till on today, we have to just close this video right at here. So I hope you getting idea about that, how we can create job setup. If you have an issue, you have to click on a job setup, and again this window is getting to be blink. So I hope you would get idea about that, how we can make the job setup in a proper and a perfect way. So in the next video we'll learn about that, how we can create the tool path. In the next video we will create turning tool path for that one component. After that we will create the milling tool path, and step by step we will learning like this. So thank you so much for watching this one video. We will see you in the next video with them some more tool path with this in some more benefits. So take care, see you soon.